Okay, so we're going to give a little presentation about TI83 and TI84 programming, and we're going to discuss a couple different problems and how to program that. First, we have the birthday problem. When a person walks into a room, there's a 365 over 365 chance that that person has a birthday, which is kind of funny, but everybody has a birthday, right? So the next person that walks into the room, as you can see, the probability that they do not have the same birthday as the first person is 364 out of 365. So the probability that two people are in a room that do not have the same birthday is 365 divided by 365 times 364 divided by 365. Now, the complement rule says that if I subtract that from 1, that's the complement of two people not having the same birthday, which means 1 minus 365 times 364 over 365 times 365 is the probability that they do have the same birthday. So going on, okay, we see that a third person walks into a room. The probability that the third person does not have the same birthday as the other two is 363 out of 365. So the probability that all three do not have the same birthday is 365 times 364 times 363 over 365 to the third power, right? So moving along, okay, the probability that a fourth person walks into a room and that at least two of them have the same birthday is 1 minus 365 times 364 times 363 times 362. Over 365 to the fourth power, and so on and so on. So what is the minimum number of people in a room where there's a 50% chance that at least two of them have the same birthday? This is really an amazing thing, okay? You would not believe it unless you tried it statistically. So the probability is actually going to be 23. So if there's 23 people in a room, there's a 50% chance that at least two of them have the same birthday, which is really unbelievable. But there's two kinds of probability. There's theoretical probability and there's also statistical probability. Now, statistical probability, I did an experiment where I had 30 students go out and get 23 birthdays. And believe it or not, 15 came back with sheets where two people have the same birthday and 15 came back where they do not. Now, the odds of that happening are not exactly great, that the probability is going to work out perfect, but it's going to be close to that, which is still a very fantastic thing. Now, to program in the TI83/TI84, which is a fantastic calculator, we're going to use these directories: program, execute, edit, control, input, output, exec, and new. So you can locate those on your calculator. But let's first go over the program. The program is going to be, you're going to clear out list 1 and 2. And you're going to store 1 into a P, which stands for probability. You're going to have a loop that's going to go from 365 to 1 down by 1 each time. So it's going to go 365, 364, 363, and so on and so on. So what happens here is 1 times 365 times 365 gets stored into P. 365 minus 365 plus 1 is going to give us 1, and it's going to get stored into list of L1 of 1, which is going to be the array that that value is going to be stored into. So 1 minus P, which is the actual probability, is going to get stored into 365 minus 365 plus 1, which equals 1. The first entry really has no meaning, okay? So we go down to the next one, right? When x is equal to 364, we're going to have P, the original P, which is 365 over 365 times 364 times 365 gets stored into P, right? 365 minus 364 is 1 plus 1 is 2. So you have L1 of 2, and then 1 minus this P is going to be the probability that they both have the same birthday. Going to the next one, only one more I'm going to do, is going to be when x is equal to 363, with the third person walking into a room. So P, the original P before, times 363 divided by another 365 gets stored into P, and then 365 minus 363 plus 1, which is going to be 3, gets stored here. That goes into L2 of 3, and the probability that there's 3 people in a room where at least 2 have the same birthday is going to be equal to that probability. And as you continue, you're going to display the answer if you want, but you don't have to because they are in list 1 and they are in list 2. So you're going to get a nice list where you're going to see 2 people in a room. What is the probability that they both have the same birthday? 3 people in a room. What is the probability that at least 2 have the same birthday? 4 people in a room. Okay, what is the probability that at least 2 of those 4 have the same birthday? And so on and so on and so on. And you'll find out from those lists when you look at them that 23 people will give you a probability of 50-point-something% that at least 2 have the same birthday. A couple other things, if you want to develop an average program for yourself on the TI83/TI84 Texas Instrument Calculator, you can apply this program. This has a while loop which keeps on going until you put in a negative number. This will sum up all your grades and divide by the number of grades that you have. When you're done, you just put in a -1 and it will get out of the program and it will display, I don't have it here, but if you want it will display your average. It's a nice little program. And finally, for people that are in Algebra 2 and above, you'll probably recognize this as a quadratic equation program. All right, so on your TI83, you can input this. This will work. This is the discriminant. Okay, this is your first root and this is your second root, and you would display both roots. So it's a pretty awesome thing, the TI83 and TI84 calculator. Texas Instruments developed the TI89, but it's too complicated for a lot of people. Not that people can't figure it out, but nobody wants something that's not user-friendly. So they were smart to keep with the 83 and the 84, which is way more popular than the 89. So thank you.